iFour Technolab Private Limited. An ISO 9001-2015 certified and leading sustainable IT service provider. Presents tutorial of smart contract using Solidity. The purpose of this course is to give you complete understanding and hands of experience with smart contracting using Solidity for blockchain technology. In Chapter 9, Structure of a Smart Contract, Part 1 covers an overview of structure of a smart contract and demystifies various structure of smart contract jargons. We are going to discuss the following topics: state variable, data types, functions, function scope and call, transactions, function modifiers. What is the state variable? Variables whose values are permanently stored in contract storage. You can declare state variables as constant. They must be assigned in this case from an expression that is a constant at the time of compilation. Example: any expression that accesses or calls to external contracts for storage blockchain data. Example: address, this, balance or block.number, or execution data, msg.value or gas left, is rejected. Expressions that may have a side effect on the distribution of memory are allowed, but those that may have a side effect on other memory objects are not allowed. The built-in functions kekik256, SHA-256, RIPE-MD160, ECRECOVER, ADDMOD, and MULMOD are allowed, although they do call external contracts except for kekik256, and except for kekik256. The compiler does not reserve a storage slot for these variables, and every occurrence is replaced by the respective constant expression, which might be computed to a single value by the optimizer. Data types in Solidity. Solidity is a statically typed language, which means that the type of each variable, state and local, needs to be specified at compile time. Solidity provides several elementary types which can be combined to form complex types. Also, types can interact with each other in expressions containing operators. Value types. Value types because variables of these types will always be passed by value, that is, they are always copied when they are used as function arguments or in assignments. Boolean, integer, fixed point number, string, address, array, literal, enum. Reference types. Complex types, that is, types that do not always fit into 256 bits, have to be handled more carefully than the value types we have already mapped. Since copying them can be quite expensive, we have to think about whether we want them to be stored in memory, which is not persisting, or storage where the state variables are held. Data location, arrays, structs, mappings. Mapping types are declared as mapping underscore key type equals greater than underscore value type. Here underscore key type can be almost any type except for a mapping, a dynamically sized array, a contract, an enum, and a struct. Value type can be any type, including mappings. Mappings can be seen as hash tables which are virtually initialized such that every possible key exists and is mapped to a value whose byte representation is all zeros, a type's default value. The similarity ends here, though, the key data is not stored in a mapping, only its kekik256 hash used to look up the value, the 56 hash used to look up the value. Because of this, mappings do not have a length or a concept of a key or value being set. Mappings are only allowed for state variables, or as storage reference types in internal functions. What is a function? Function. Executable units of code within a contract. Example: function parameters and return variables. Functions can take parameters as input, as in JavaScript. Functions can also return an arbitrary amount of values as output, unlike in JavaScript and C. Function parameters. Function parameters are declared the same as variables, and it is possible to omit the name of unused parameters. Return variables. After keyword returns, function return variables are declared using the same syntax. Function scope and call. What is the function scope? Function scope defines the accessibility of the function within and outside of the contract. It can be divided into three parts: public, internal, external. Public and external differs in terms of gas usage. The former uses more than the latter when used with large arrays of data. This is due to the fact that Solidity copies arguments to memory on a public function, while external read from call data, which are cheaper than memory allocation. Public functions are called internally and externally. Internal calls are executed via jumps in the code because array arguments are passed internally by pointers to memory. Internal calls are executed via jumps in the code because array arguments are passed internally by pointers to memory. When the compiler generates the code for an internal function, that function expects its arguments to be located in memory. That is why public functions are allocated to memory. The optimization that happens with external is that does not care for the internal calls. So if you know the function you create only allows for external calls, go for it. It provides performance benefits and you will save on gas. Example. Here, in the example provided, we are using the public as a scope, so this function can be called within a contract as well as outside of this contract. The public can be replaced with internal or external to avail of the related benefits. Calls. A function call is calling a function to execute it wherever required to reduce the lines of code. Types of a function call. Internal function calls. External function calls. Function call. Internal function calls. Functions of the current contract can be called directly, internally, also recursively. Example. These function calls are translated into simple jumps inside the EVM. This affects that the current memory is not cleared, that is, passing memory references to internally called functions is very efficient. Only functions of the same contract can be called internally. You should still avoid excessive recursion, as every internal function call uses up at least one stack slot and there are at most 1024 slots available. The function call. External function calls. The expressions, where C is a contract instance, are also valid function calls, but this time, the function will be called externally, via a message call or directly via jumps. Please note that function calls on this cannot be used in the constructor, as the actual contract has not been created yet. Example. Functions of other contracts have to be called externally. For an external call, all function arguments have to be copied to memory. A function call from one contract to another does not create its transaction, it is a message call as part of the overall transaction. When calling functions of other contracts, you can specify the amount of way or gas sent with the call with the special options .value and .gas, respectively. Any way you send to the contract is added to the total balance of the contract. You need to use the modifier payable with the info function because otherwise, the .value option would not be available. Value option would not be available. Transactions. What is a transaction? In Solidity version 0.4.24, constant is used instead of the view, which we discussed earlier in the function scope. Constant is deprecated and will be dropped in version 0.5.0. identify transaction and a function. If a constant keyword is present in the function declaration part, then it is a normal function, else it is a transaction. The transaction creates a new block in the blockchain and saves the transaction-related data in that block. Example. Here, in the example provided, constant is missing, which makes it a transaction. An invoice structure is taken having various fields like ID, to, from, amount, subject, status and created at, which produces a new invoice variable with the values generated by invoice structure. At last, whatever is stored in new invoice variable is pushed into an array named invoices to keep the track of all the transactions held or performed. Modifiers. Function modifiers. Function modifiers. It is used to amend the semantics of functions in a declarative way. Modifiers can be used to change function behavior easily. For instance, before executing the function, they can automatically check a condition. Modifiers are contracted inheritable properties and can be overridden by derived contracts. Example. Function modifiers are a special function that cannot be called directly but is used to add some modification or additional check to a feature. Let's say you have a function that needs the sender to send some Ether. You can use a modification function that needs at least one way. What is happening here is, it reads first line, require the message sender to send on or more than one way to continue. The function will be reverted and cancelled if that statement returns false. The second line calls false. The second line reads, from here the function bodies that the modifier is attached to continue. The steps will be, the user will call that function, and the modifier will first be called to confirm the statement. It will be, call function test modifiers, require validate message value and require the owner of the contract. Owner because is a private method. That's it in this video. Thank you for watching and stay tuned for our next video.